record on this.
You're going to record it.
Okay, so we're now recording. So we've got two vectors, Sophia. We've got vector A, and vector A is going to be 3, 4. And that means it goes along by 3 units.
Did you write this down?
And up by 4 units. Now I'm going to run out of space there, so it's going to go all the way up by 4 units. There it is. Okay, so that's vector A, along by 3, up by 4. Okay, if I wanted to find out the magnitude of vector A, I need to know the length of the line. So in this case, it's the length of the line from the start to the finish of vector A. That's vector A. Now to do that, we use Pythagoras. So for Pythagoras on this, we've got the length of vector A, magnitude of vector A is in modulus signs, those are the two little lines, and that is 3 squared plus 4 squared, simple Pythagoras, and we need the square root of that. And the magnitude of A is going to be square root of 9 plus 16, extend that, equals root 25, which is equal to 5 units. So that was fairly easy. Right. What we can now do is also define another vector. Let's call it vector B. Vector B will make minus 2 and 1. Keep it a little smaller. So negative 2 is going to be 2 this way. And then it's going to be 1 up. So it's going to be 1 up there. So it's going to start here and finish there. And draw that vector in there. So if I've got that vector, call that B. Magnitude of B is equal to 1 squared plus 2 squared square root, which is equal to root of 1 plus 4, which is root of 5. So we've got the magnitude of B is root 5 units. Now that's roughly 2 point something. 2.2 maybe.
So are we copying this down?
You can copy this down, yes. If I now take A and I want to do the magnitude of A minus B. So this is a combined vector. So let's define that as C. C equals A minus B. So from before we know that to do A minus B, we can either do them using diagrams, which is what we'll do this first one, and then we'll do it just using numbers. So using diagrams, we start with vector A. Vector A goes along by 3, up by 4. That's A. And then minus B. So vector B goes along by 2. This is minus B. So this is 2 and down by 1. So this vector here is going to be negative B. It's the opposite of B, which is up there. That one's B. Okay, so our overall vector on this is from here all the way to here. We've built up those vectors. Now, there seems like there's a lot of lines on this, but just counting the squares, 1, 2, 3, 4, 5, 5 along, and 1, 2, 3 up. So C, vector C, is equal to 5 along and 3 up. So the magnitude of C, which is equal to the square root of 5 squared plus 3 squared, and we have equals the root of, we've got 25 plus 9, which is equal to the square root of 34.
Can you sit down because we have time to write the notes and then also
Okay.
sync the information in?
Yeah, I'm stopping now.
Okay.
Right. So, last bit with this. The same vector C we can do purely with numbers. So vector C we could have done like this. With A and B, it's A minus B. So A, which is 3, 4, minus B, which is minus 2, 1. And that's equal to...
You can pause the video.
as I said, I'm just recording this, and I am going to stop in a second. 3 minus minus 2 is 5. 4 minus 1 is 3. Okay. So we get to the same vector there. You don't have to always draw a diagram, that means. Okay, I'm going to stop there. Any questions about the content? Amy?
You know on B, where's the -2?
Yeah, that's what I was on.
Right, on B where the -2 is this one here. So going from there to there, -2 means go backwards by 2.
There's the bottom.
Put -2 into the Pythagoras.
If you put -2 into the Pythagoras, when you square it, what does it become? Positive. It's from where you start to where you finish. So if you mark your start and finish and you put an arrow on it, some of the arrows are a little small on these, but if you put the arrows on them, they work out.
So I found all sound.